Okay, so just a little bit of review quick. Sorry I did not turn the recorder on right away. So, as a quick review, okay, and you people can benefit from this as well. So, here we see two compounds. Here we see two compounds that have the same exact molecular formula, but they got a different structure. So what had happened is we took this carbon off and moved it to the middle. That's why we say X marks the spot. Now we're going to do something very similar here. We're going to remove this carbon, and someone pick a number between 2 and 4. Okay, so 3 is the first one that I heard. We're going to take this guy. We're going to say X marks the spot here. And now, this was hexane at one time because it had how many carbons? It had 6. Now in this parent chain, okay, that's something that we haven't dove into that far in depth. But now how many total carbons are there? There's 5, in the straight chain, but there are 6, but it's in a different location. So, what we do with these is when we're naming these branched chains, okay, and that's what this is. That's what a lot of isomers are. It's branched chains from the parent chain. Now, you're going to say we're using that term quite a bit, which we are, okay? So, you correctly called this butane, okay? And when you name these compounds, the first thing you're going to want to do, and you got to let me know, are we going too fast? Like left outside, is anyone confused with what we've talked about the last 15 minutes? Left outside. And I'm sorry, let's say, are we on the bus? Are we good? Left middle, middle, right middle, right outside. Okay, so when you're nodding your head yes, and everyone did, we're saying we understand this, so it's not that we're going faster, but we're going to keep moving forward. Okay, so what we mean by that is, first of all, you're going to want to find the longest continuous chain, which was 4. That's why it's called butane. Now, the longest continuous chain here is how many? It's 3. Okay? It's got 4 carbons in it. Yes, that's true. But the longest continuous chain is only 3. So when we're talking about a compound with only 3 carbons in it, okay, what is the prefix for that? What's a 3 carb? PROP. Okay? And in this case, it's still propane because this is a saturated hydrocarbon. Because all the bonds in there are termed as what? They're all single bonds. So it is saturated. Okay? Now, when we say X marks the spot here or X marks the spot there, we need to name what that is called. So, for instance, when we look at element 26 on your periodic table, that is which element? Well, you're right. So when we look at that element iron, what is its symbol? It's called Fe. Well, there again, why are we calling Fe iron? That doesn't make any sense. It's Latin. There are other examples like element 50. What's element 50? Well, what's the abbreviation for tin? Well, there's no S in tin. The Latin term, the Latin name for tin is stannate. The Latin term or Latin name for iron, does anyone know that? If something is magnetic, that means it's this type of metal. No. Close. It's a what type of metal? A magnet picks it up, so it's got iron in it, so it's this type of metal. I know you've heard of it. No, it's a ferrous metal. So what does ferrous mean? Ferrous means iron, right? No, not a Ferris wheel. But, so, iron is derived from the Latin term. What does it mean to be derived from something? Not so much inspired. And say that again. Taken away? No. It means where it comes from. Okay? So, for instance, earlier I said, yep, got my green jacket on. That's derived from the idea that the person who wins the Masters wears a green jacket. It's derived from that. That's where it comes from. So what we mean by that, when we're talking about this derivative, a derivative means you derive it from something. Just like ferrous is Latin for iron. It's derived, it comes from the Latin term. So what we mean by that, this is what we call a derivative, right here. Okay? Inside that box, inside this box, inside this box. What is the molecular formula of that derivative? 1 carbon and how many hydrogens? 3. So it's no coinky-dink or coincidence that what we see here, what does that tell you? CH3. Okay? Now, this X, just like what we see, X marks the spot here, here, I guess you could have said up there, but that is what we call a methyl group. Because if we leave this as just a hydrogen atom, if it's CH4, we know, what's that called? Methane. But this is not a hydrogen atom. It's bonding to a carbon. That's why we see that X up there. So we derive methyl, M-E, let's about had it, M-E-T-H-Y-L. Because methyl resembles what? Say that again. Methane. Is anyone confused with that intuitive leap? That means you're making, not such an educated guess, but you're making sense of something as an intuitive leap. Is anyone confused on how this is called a methyl group? This is a pretty important deal right now. Left outside. Are we on the bus? Methyl group. Left middle. Middle. Right middle. Right outside. Okay. So if a methyl group has a formula of CH3, which it does, what do you notice inside this box? What's the formula for that? CH3, which we have established is a what type of group? Methyl group. So what that means, okay, the last thing we need to illustrate is where you see that X, which carbon atom is that on? The second carbon. It doesn't matter which direction you go, whether it's going left to right or right to left, 1, 2, or 1, 2. So on the second carbon, there is a methyl group on the parent chain of propane. Okay, difficult concept, a big leap here. Left outside, are we still good? Left middle, middle, right middle, right outside. Okay, so if that is the case, we're all nodding our head yes. How do you think we're going to name this guy right here? It's no longer hexane. It's pentane. Okay? So we'll just put that here, pentane. Okay? Is there anything coming off of that pentane? Yes. A what type of group? It's a methyl group. Where is that methyl group located? 3. On the third carbon. Okay? Actually, I didn't leave enough room there. I'm going to rewrite this. Okay? So we had pentane. Okay? And you correctly said we've got a methyl group. And that methyl group is on the third carbon. Okay. So if we break this down, okay, our organic family is denoted right here. Anything that ends in ANE is called a what type of, yeah, it's a hydrocarbon, but more specifically, what type of hydrocarbon compound? It's an alkane, okay? So anytime you see this term, ANE, this suffix as an alkane, we know this is a saturated hydrocarbon, okay? What do you suppose this PENT is telling you? That's a prefix that there's 5 in the parent chain, okay? We gave this as a derivative. What does methyl mean? What's the formula for a methyl group? No, close. Not CH4, that's methane. CH3, and then what is this guy telling you? Where it's located. Okay, so we reverse engineered this. This is your organic family. This is the parent chain. This is denoting anything branched off of that parent chain. That was a lot of material in just a short amount of time. But you've got to say something. I know it's human nature. Please get in and talk to myself. Anybody else who has a good understanding of this. Who is thinking this is not that bad and I feel I have a really good grasp on this. Get them up high. Okay, so for those of you who are maybe just a little confused, look around in the room. Look at those hands that are up high. They can help you if you choose. Myself, there's 3 seniors that can help you with this. Maybe even another staff member. But it's got to be your choice to do that. And we've gone through that all this semester. Okay. So, what is the formula? If we had hexane, what's the formula for hexane? C what? H14. If we had 3-methylpentane, what is the molecular formula for that? How many carbons are there? 1, 2, 3, 4, 5, 6. How many total hydrogens are there? So what does that mean that these 2 compounds are what of one another? Just like what we see up here. Remember, an isomer is that of a chemical compound that has the same molecular structure, whether it's C4H10 or C6H14, but a totally different structure. Okay. We're not going to go into this group yet, but if CH4 is methane and CH3 is a methyl group, C2H6 is called what? Ethane, but if we have C2H5, it's not ethane, but what type of group if you follow that pattern? Methane went to methyl. Ethane will go to ethyl. Now, that's as far as we go, okay? Because in 2 years, for those of you who take general chemistry, this comes full circle. You have to know a methyl group, an ethyl group, a propyl group, and then an isopropyl group. Then if you really like this stuff, as a senior with organic chemistry, you need to know a methyl group, an ethyl group, a propyl group, an isopropyl group, a butyl group, an isobutyl group, a tertiary butyl group, and I think there's one I'm missing. Secondary. So 2 this year, 4 next year, 8 when you get to be a senior. Okay? For those of you who choose to take this. Now, the only way that, well, I shouldn't say the only way, the best way to be successful with that is to stay current with that, to keep up with it. In other words, if you don't serve very well in volleyball, what does that tell you should do? Work on your serves. If you really don't know your runs very well in a clarinet or a flute or a trumpet, what does that tell you you should probably do? Probably work on it. Okay? Maybe quit. That's entirely up to yourself. Or if, just think, you're in the Final Four and you're down by 2 points. How many of you want to be Kyle Guy? Who's that? Guard for Virginia. Okay? And if you watch the national championship, I think it was a reporter that asked him, so what was going through your mind? And his response was probably pretty good. He said, going up to that free throw line, I thought to myself, I'm either going to make one or all 3. Okay? Making 2 of them never really crossed his mind. He thought, and I think that would be the case if you go up there and you miss the first one. Okay, well, all right. I still got 2 left, down by 2. And just think, you shoot that second one, and that didn't go in. Oh, geez. Now you have 1 free throw left, and you're down by 2. But how many do you think, well, those of you who play basketball want to be on that free throw line with very little time left and knowing you got to make at least 2 of those 3. Maybe making 1 is bad enough, but have to make 3? How many of you could just walk right up there, do you think? And just, you just got to what? That's a lot of time to try to get that. That's a strategy, but I don't think you really, especially when the clock has stopped. For those of you people who play basketball, is that good advice or good coaching strategy? I didn't say it wasn't cool, but is that a good coaching strategy? Oh, I stand corrected. Okay? All right. So, can we erase this? Is there any questions on this before this is disappearing? Okay. I'm going to throw a curveball here, or a slider. See if anyone, or maybe see if I can get a fastball by you. Okay. Okay. What compound do you think it is? First of all, we said, what do you have to do first? Count longest continuous chain of carbons. Okay? So, someone tell me, what compound do you think we have? Okay, I hear heptane and I hear hexane. Who says heptane? Okay, well, I thought I heard it. Who says hexane? So, but whoever said heptane, that was right. Why is your hand going up now? Did you not understand the... Oh, okay. So, when we look at that, okay, there is no such thing as having a derivative on the first carbon. It has to have a number 2 or greater. So, if you were saying hexane, there's no such thing as 1-methylhexane. It doesn't exist. This is still heptane. So, with that, let's do... Okay. Okay. Okay, again, find what? The longest continuous chain. And that is what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, 6 is what? Hexane. Okay, is there anything branching off of that hexane? Yes. Okay, so what is branching off of that? Well, we should probably make it a little simpler and just do this. Okay, what is branching off of that hexane? Okay, a methyl group, and it's located on which carbon? Okay, so we've got, well, wait a minute. Wait a minute. This is right. 1, 2, 3, 4, 5. Isn't there a, wouldn't we say 5-methylhexane? It's either 5-methylhexane or 2-methylhexane. How many of you think it's 5? No takers? You all think it's 2? Yeah, it's actually 2. So what we see here is we've got 2-methylhexane. So again, remember, you can always reverse engineer this. This is telling you have an alkane, which means there's no double bonds, there's no triple bonds. Everything is single bonded in there. Okay? This is telling you what? We're putting a hex on you. Isn't that how you got to wave the fingers like this? Putting a hex. No. Maybe it's just like this. You don't have to move the fingers. All right. Hex means what? 6. Okay? So we got a 6-carbon compound. 1, 2, 3, 4, 5, 6. There they are. Everything's single bonded. Okay? This is telling you on your second carbon, 1 and 2, that you have this, which is a what? It's a methyl group. Okay. If you are struggling with this, okay, so the last thing we'll write down. What is the molecular formula for this? This is the structural formula. What is the molecular formula for this? How many carbons are there? 1, 2, 3, 4, 5, 6, 7, 16, right? Okay. So 3, 5, 7, 9, 10, 13, and 3 gives you 16. All right. We'll continue with this again tomorrow. Catch up with you next time.